So relations complete chapter revision, let us see here. The first thing is that relation definition. Relation R is a non-empty set. If you are taking from a non-empty set A, another non-empty set B is a subset of the A cross B. A cross B is nothing but what? A cross B is the Cartesian product of the two sets. A cross B is nothing but Cartesian product. A is the one set, B is the another set. Okay. So detailed we are going to learn. A and B are two sets means. So any subset of the Cartesian product of the two sets is considered as a relation. So the subset R is derived by describing the relation. Suppose let us take the one example here. A is the set 2, 4, 6, 9 and B is the another set 4, 6, 18, some set. Find a relation from A to B such that A belongs to B, B belongs to B, such that A is the factor of B and A less than B. Factor means first element should be the factor of second element, means Cartesian product will contain the ordered pairs. Cartesian product will contain the ordered pair. So A is the factor of B you need to find out. So A comma B is an ordered pair in which A less than B you need to, means A factor of B you need to take into consider. A is the factor of B. So now normally if you take that first element 2, 2 is the factor of which of the elements present in the set B? 2 is the factor of 4, 2 is the factor of 6, 2 is the factor of 18, 2 is the factor of 54. So you will get in this relation 2 comma 4 aayega, 2 comma 6, 2 comma 18, 2 comma 54. Samajh mein aaya na? Because 2 is the factor of all these numbers. Like that you take the 4. 4 is the factor of which elements? That factors only to be taken into consider at 6 and 9. So like that whenever you are taking into consider here at the elements here, you see here clearly observe here 2 comma 4, 2 comma 6, 2 comma 18, 2 comma 54 and 6 comma 18 is given because 4 se kuch bhi nahi le liya. So why? Because 4 is the not factor of the any one of the numbers present in the set B. Actually 4 is the factor of 4. 4 is the factor of 4, but 4 should be less than 4 it is given now. So 4 less than 4 nahi hai. So that's why 4 se kuch nahi aayega. But 6 if whenever you are taking 6 and 18, 6 3 is 18 hai na? 6 is the factor of 18. So like that you can all the ordered pairs whenever you are taking. All the first elements whenever you are taking into consider, all the first elements are called as a domain and all the second elements in the relation are called as a range of this relation. It is called as a range of the relation. Okay, is it clear to you? So domain is so here in this, if A comma B belongs to the relation, we say that A is related to B and we denote that one by the A or B, A capital or B. So if n of A is equals to P, n of B is equals to Q, then n of A cross B means in the Cartesian product of the two sets will contain the product of the number of elements present, P into Q. Then the total number of possible relations are total number of possible subsets you are going to get. So total number of possible subsets, if a set containing the n elements, if set contains the n elements, then number of subsets kitna hai? 2 power n. Number of subsets are 2 power n. So here whenever you are taking into consider, number of subsets are 2 power n. PQ are the number of elements in A cross B, P into Q. So that's why number of relations we will get 2 power PQ. Number of relations you get 2 power PQ. Okay. So now one more example, see A is the one set containing the element 1, 2, 3, 4. If A is the element 1, And what is the ordered pair? Means Cartesian product of the A cross A means 1 comma 1, 2 comma 1 comma 2. This is Cartesian product, you know that. A relation x plus y is equals to 15. X plus y is equals to 15 in the set. Okay, so that you need to find out. Means sum of the two numbers should be is equals to 15. ऐसा वाला numbers find out करना है. So any relation in the R and a subset of means any two elements in that A cross A, if you add, whether you will get 15, no chance. So that's why that type of the, there is no relation, such type of the relation means there are no ordered pairs, such type of the ordered pairs are not at all present there. So that's why it is an empty set. So such type of the relation is called as a empty relation. This is a type of the relation. So that relation is called as, it is relation is also a set. What is that one? It is the subset of the Cartesian product of the two sets. It is a subset of the Cartesian. So empty set relation, empty relation definition here. A relation on a set A is called an empty relation if no elements of A are related to the any element of here. So that is called as an empty relation. Okay. So now if you take the another example, if question is given to you x plus y is less than or equals to 8. X plus y is less than or equals to 8. So when x plus y is less than or equals to 8, what conditions you are going to get? 1 comma 3 less than or equal to 8. 1 comma 1 also less than or equals to 8 you are going to get it. 1 comma 2 also less than or equals to, because 1 plus 2 is 3 now. So like that, whenever what are the elements are there in the set A, that all which will satisfy that condition. What is the condition here? X plus y less than 8 is the condition. So the relation is equals to A cross A only, because all the elements in that set are will satisfy the less than or equals to 8 only. Any two elements you take, less than or equals to 8 only you will get in the A cross A. So such type of the relation is called as a universal relation. It is called as universal relations. Universal relation is nothing but that set itself, that Cartesian product itself is called as a universal relation. Cartesian product itself is called as a universal relation. Empty relation and universal relation are called trivial relations. They are called. It is not there in your textbook. And in the relations you are having types of relations. This is examination point of view very important. Reflexive, symmetric, trans2. If a relation is reflexive, when do we call the relation is reflective? Means let T is the set of all the triangles in a plane. In a plane, all the triangles will. R is the relation in a T defined by T1 comma T2 whenever you are taking. T1 is similar to T2. Similar to triangle should be similar. So then you can say that. So T1, T2, T1 is similar to T2 means T2 is also similar to T1. So that is different case. And here every triangle is similar to itself. Reflection is nothing but if A is present in the set, A comma A should be present in the relation. If A is present in the set, A comma A should be present in the relation. Okay. So here what is the relation? T is a reflexive relation because every triangle is similar to itself. वो खुद को similar हो सकता है, same triangles. Okay. So symmetric relation is nothing but if any element is present, A comma B is present, means B comma A should be present. Actually, definition is that if A comma B present in the relation, B comma A also should present in the relation. So T1, T2 are the two, T1 comma T2 present in the relation means T1 is similar to T2. Then T2 is similar to T1, you can say that. T2 is similar to T1 also, you can say T1. If A is similar to B, B is similar to A, means similar is nothing but triangle. One triangle is similar to other triangle. So then you can say that T2 comma T1 also belongs to the relation. Then that case, that type of the relation is called as a symmetric relation. A relation in R, a relation R in the set T, T is what here is said to be a symmetric. If x comma y belongs to the relation means y comma x also should also belongs to the relation. For all x comma y belongs to T. This is called as a symmetric relation. Next, trans2 relation. Trans2 is nothing but x comma y belongs to the relation and y comma x belongs to the relation. Y comma z belongs to the relation. Then x comma z also. Sorry, this is symmetric relation. Symmetric relation, one example it is showing to you. Then after we'll go to the Trans2 relation. Now here you see that one thing is given. Example is that a relation is given 1, 2, 2, 1, 1, 3. In the set of 1, 2, 3 is not a symmetric relation because 1, 3 is present, but 3, 1 is not present. 1 and 1, 3 is present, but 3, 1 is not present. So it is wrong to say that it is sometimes symmetric and sometimes as far as 1 and 2 are concerned. Only for some cases, sir, 1, 2 present, 2, 1 present. So in that case, it is satisfying the condition. So it is symmetric. No, you are not supposed. It should satisfy all the ordered pairs which are present in that relation. For all the ordered pairs, it should be taken into consideration. Okay. So this is called as a symmetric relation. It is called as symmetric relation. So it should not for all the ordered pairs. That means what are 1, 3 present means 3, 1 should be present in that. Now let us move to the Trans2 relation. Trans2 relations. Which relation is called Trans2 relation? A relation R in the T is said to be Trans2 relation if x, y belongs to the relation and y, z belongs to the relation, implies x, z is also belongs to the relation. Then for all x, y belongs to T. T is what here? Defined on a, means R is a relation defined on a T. Normally A will be given to you because we have taken here triangles, similar triangles, so that's why we are getting here. So T1, T2 and T3 belongs to the T. T1, T2 belongs to the relation, T2, T3 belongs to the relation you consider. That is nothing but T1 is similar to T2, T2 is similar to T3. A equal to B, B equal to C means A equal to C we will get now. So like that, here similar condition also will satisfy. So T1 is similar to T2, T2 is similar to T3, then T1 is similar to T3. T1 is similar to T3. So it is satisfying in case of the triangle similarity. Triangle similarity in case may satisfy both. So that's why we can say that it is Trans2 relation. So this is Trans2 relation. Okay. See, if a relation is reflexive, symmetric, Trans2, then that relation is called as an equivalence relation that we are going to learn. The relation R is reflexive, symmetric and also Trans2. Then that relation, if it is any relation is satisfies the three conditions, means 3, reflexive, symmetric and Trans2, then that relation is called as a equivalence relation. That is called as equivalence relation. So a relation is said to be equivalence relation if it is reflexive, symmetric and also Trans2. 3. Okay, 3 relations, 3 types of the relations may satisfy one. Suppose sometimes most of the students will get confused that anything it is showing now. So here, let us take the one example here. This is A set containing the 1, 2, 3, 4 elements and B set containing the elements A, B, C, D, E. And here the relation is given to you. Okay, 1 to A, 2 to B, 3 to C and 4 to D is given. So this is relation. Okay. So now here 1, A, 2, B, 3, C, 4, D. So another one function. Functions, whenever you are going to take into the functions, types of the functions may. So here 1 function, which is called as a 1 function. Which type of the function? Now means the function is called as a 1 function if it is having a 1-to-1 relation. So function is nothing but here f from A to B is defined to be a 1 function if the images of the distinct elements of A under F is distinct. Means different elements of A should have the different images. Same image nahi hona. So that is nothing but from the domain say you are not supposed to have the arrow marks to the single element. So इधर से एक element को arrow mark है तो दूसरा element को. So to prove that any function is 1 function, this is also important. The question may be given to you to prove the 1 function onto function. 1 function prove करने के लिए f of x1 is equals to f of x2 we have to take and we need to prove that x1 is equals to x2. F of x1 is equals to f of x2 is nothing but the images of x1 and x2 are equal. then that two elements are same elements, we will say. So a 1 1 function, is this a 1 1 function? No, because 3 and 4 are having the same image, that is minus 3. So that's why this function is not a 1 1 function. It is not a 1 1 function because 3 and 4 are having the same image, that is minus 3. Then in this case it is not a 1 1 function. So it is called many to one function. Many elements are mapped to single elements. So whenever you consider that a function, if it is given to you like this, actually before going to that you need to know that what is meant by a function. What is the definition of the function? What is the definition of the function? Function means actually a relation, that is also a relation. A relation is called as a function if every element of the domain is having a unique image. Every element of the domain means every element means domain, say in left hand side, whatever the function you are taking, set you are taking, from that every element should have the one image. Only image, not two images. Unique is nothing but not different. Unique is nothing but only one image only should be there. Then only it is called as a function. Then the types of the functions, whenever we consider 1 1 function and onto function and bijection. 1 1 function is called as an injection, onto function is called as a surjection, and if a function is both 1 1 and onto, it is called as a bijection. So we are now learning the 1 1 function. So here if a function is given to you like the in an ordered pair, so 12 comma 2 is given. So that is nothing but f of 12 is 2. F of 12 means 12 is mapped to 2. So it is written as f of 12 is 2. The image of 12 is 2. The pre-image of 2 is 12. We call it as a pre-image of 12 is, pre-image of 2 is 12. Image of 12 is 2. So like that, but we write it as f of 12 is equals to 2, f of 15 is equals to 4, f of 19 is equals to minus 4. Like that we will continue to write this one. Okay. So g function, if it is given, also see f of 12 is equals to 2, f of 15 equal to 4, f of 19 is minus 4. G function also in the same way. Function g whenever it is given. So if it is given to you like that, whether it is a 1 1 or not, how do you identify? Second ordered pair means in the ordered pair, second element should not be same. First set you consider 2, 4, minus 4, 0. All are different. All are different. That is nothing but different elements are having different images. Second one you take 9 comma minus 4. Minus 4 is repeated twice there. Minus 4 is repeated twice. So definition is what here, if you consider the one function defined by f of x is equals to 2x, and how do we prove it as a 1 1 function? 1 1 function हम लोग prove करना पड़ता है. So first you will consider that two different images, x1 and x2 are two different elements in the domain R. Domain में consider करना है, and such that f of x1 and f of x2 are equal. That is nothing but two elements here it is taken, and it is mapped to single element because f of x1 is same, f of x2 is also same. Both are equal. We will consider that both are mapped to one element. By considering this, when both are mapped to one element, both are not different, same elements, means x1 equal to x2 prove karna. So simply 2x1 is equals to 2x2 and x1 is equals to x2 by dividing by 2, we will say that the function is, this function is a 1 1 function. Like this. Different cases. Suppose if you are taking x square, f of x is equals to x square. So x square by x1 square is equal to x2 square आएगा. Square if it is there. Whenever square it is there, square whenever it is there, then you can say that. Now graphical representation, through the graphical representation also, whether the function is 1 1 or not, you can identify. That is, the graph of the function f of x is equals to 2x is like this. F of x is equals to 2x whenever you are taking. So the horizontal line test, we call it as a horizontal line test. You draw the any horizontal line for the given graph. If the horizontal line is touching the given graph at 2 points, if it is touching the graph at 2 points, any horizontal line, then it is not a 1 1 function. It should touch at only 1 point only. If it is touching at only 1 point, then this function you see horizontal line, किधर भी horizontal line draw करो, वो एक ही जगह में touch होगा. Then this function is 1 1 function. फिगर देख के बता सकते हैं। पहले वाला ये देखो 2 places में टच हो रहा है, horizontal line draw कर लिया, then it is not a one function, it is called many to one function because 2 different elements are having the same image. So now let us move to the onto functions. Next topic is onto functions. So what is meant by an onto function? In the codomain, every element of the codomain should have the some pre-image. Means second set में खाली कुछ भी नहीं होना है. Second set में means second set is nothing but codomain. So codomain में no element should be empty. So every element should have the some pre-image. Some pre-image. Here codomain is what? Here 5, 6, 7, and the range is 5, 6, 7. If codomain and range both are equal, then also you can say that it is a onto function. If codomain and range both are equal, then it is called as an onto. Original mathematical definition is what? Every element of the codomain should have the some pre-image, at least one pre-image. You may have the 2 pre-images. Either देखो इस problem में 6 को 2 pre-images आते हैं, 3 and 4. And before that it should be a function. First it should be either it is a function or not. Yes, it is a function. Every element is having one image only. 1 को 1 image है, 2 को 7 1 image, 3 को 6 image. It is not a one function because 3 and 4 both are having same image, but it is onto function. Why it is an onto function? Right side में, that is nothing but codomain में every element is having some pre-image. So pre-image is nothing but before the whatever it is there. So for every element of y belongs to B, if there exists x belongs to A, such that f of x is equals to y, then that function is called as a onto function. Okay. So now you see this function, whether it is an onto function here. 5, 6, 9, 11 are there? Yes, it is an onto function. F is an onto function. Okay. So this one, no, it is not onto because 4 is not having any pre-image. Khali pada hai. So that's why it is not onto. This is an easy task to us to identify when the graph is, when the function is given to you like this. If the function is given. Next, bijective functions. The functions which are called as bijective functions. A function which is both 1, 1 and an onto, then that is called as a bijective function. If a function is both 1, 1 and onto. So a function f from a to b should be 1, 1 function and as well as onto function. Then that function is called as a bijection. It is called as bijective function. See here, a function f is defined from a to b is defined to be 1, 1. If every element of a is mapped to unique element of b, or the name of the 1, 1 function is, another name is injective function. Injective. Okay. Onto bole to surjection. Actually, injection, surjection. Okay. So onto function, another name is surjection. If a function is both 1, 1 and as well as onto, then that function is called as a bijection function. So surjective function. Onto another name is what? Surjection. Simply surjection you can say, or surjective function you can say. So when we say the function is surjection, every element of y का pre-image same, every element of the codomain should have the some pre-image. एक तो एक pre-image होना है. So it is said to be bijection if the both it is 1, 1 and as well as onto. Okay. So now if you are taking x as a one set which is containing the elements a comma b comma c, define a function f from x to x such that it is 1, 1. You give the one example that it is 1, 1 function. X to x only it should be defined. So different cases are given to you. First case, whether it is a 1, 1 function, yes. Second one, yes, it is 1, 1. Third one, it is 1, 1. Fourth one, all are whatever it is given to you, 1, 1. Different cases are given to you. So number of 1, 1 functions here it is going to say. So if a range of the function f is a comma b comma c. Okay, range of the function is a comma, and range of the f is equals to codomain. Range of the f is also codomain equal. So if codomain and range both functions are equal, of a function are equal, then that function is also called as a onto function. So it is onto. function another name is mapping. Here mapping is there, hence one mapping is given. Mapping is nothing but the another name of the function is mapping. Okay, so a one function f from x2 is necessarily onto for any finite set of x. Okay, so this is the one condition, and an onto function is necessarily one for any set, for any finite set on x. So these are the points you need to note here in this situation. Okay, one function should be, so suppose let us take that an onto function is necessarily one for every finite set x. That is nothing but define a function f from x to x such that onto वो onto होने की तरह अब define करना है. Okay, to show one function we have to assume that f is not one function. Then two elements of the domain of x are mapped to the same element in the codomain. If it is not one function, two elements of the domain are mapped to the single element, same element in the codomain of f. If it is, you consider it as a, if it is not one function. So that is nothing but whenever you are saying this one, range of the f in this situation, range of the f is not equals to codomain. Range of the f. So range of the f not equal to codomain means it is not a onto function. It is not an onto function. Hence an onto function is defined from a finite set itself is always one. अब वो one होता है तो onto होता है. Okay, on a finite set, single set में define होगा. Okay, so this is about the different types of the functions, one function and onto function. Okay.